My presentation is on Andrei Sakharov. He was born on May 21st, 1921 in Moscow, Russia. His family was well educated and deeply connected to science and the arts. His father was a physics teacher and also wrote science textbooks. This sparked Sakharov's interest in scientific discovery from a young age. Growing up in Moscow during the early Soviet period meant that he experienced both the hardships of political change and the excitement of rapid industrial and scientific progress. These early experiences shaped his worldview and gave him both the curiosity and determination that would later define his career. He graduated from Moscow State University in 1942 with a degree in physics during World War II when the Soviet Union was facing enormous struggles against Nazi Germany. Even during this difficult time, he focused intensely on his studies and research. In 1947, he earned his PhD in physics from the Lebedev Physical Institute in Moscow, one of the most prestigious scientific centers in the USSR. It was here that he began his groundbreaking work in nuclear physics. This made major contributions to the Soviet thermonuclear weapons program. His research at this institute laid the foundation for advances that would have global consequences during the arms race. It was during the Cold War, a time when the USSR and the USA were locked in fierce competition over nuclear weapons, space exploration, and ideological dominance. The two superpowers invested massive resources in science and military technology, and scientists like Sakharov were at the center of the struggle. However, inside the Soviet Union, life was tightly controlled. The government censored newspapers, controlled what people could say publicly, and punished anyone who openly criticized official policies. Speaking out against the government could cost a person their career, their freedom, or even their life. This tense atmosphere of repression influenced many of Sakharov's choices later in life when he began to question the morality of his scientific work. He was a key figure in the Soviet atomic bomb project, helping to ensure its success during the early Cold War years. His designs for the hydrogen bomb, in particular, gave the USSR a powerful weapon that matched the capabilities of the United States and changed the balance of global power. Beyond just weapons, his inventions and theories had lasting influence in particle physics, helping scientists better understand the structure of matter at a fundamental level. These contributions made him one of the most important scientists of the 20th century, though they also weighed heavily on him as he began to think about the human cost of nuclear warfare. Later in his life, he dramatically shifted his focus and began to speak out against nuclear weapons, despite the risk of doing so in the Soviet Union. He argued that continuing to build and test these weapons threatened humanity's survival, and he called for limits on nuclear arms. This was a bold move that transformed his reputation from a respected scientist to a controversial dissenter. In 1975, he was awarded the Nobel Peace Prize for his efforts in advocating for disarmament and human rights. The Nobel Committee praised his moral courage in standing up to the Soviet government, and the award gave him international recognition and support. This moment marked a turning point in his career, elevating him from scientist to global activist. He became a powerful advocate for human rights, calling out the injustices of Soviet repression and totalitarian rule. He worked with other intellectuals and dissidents to organize groups that wrote petitions, published statements, and demanded more freedoms. His writings and speeches traveled far beyond the Soviet Union, inspiring movements for democracy and civil liberties around the world. For many inside the USSR, he represented a voice of courage at the time when speaking out, knowing that it could lead to punishment. His bravery encouraged others to continue pushing for change even when the odds seemed impossible. Because of his outspoken criticism, the Soviet government punished him harshly. In 1980, he was sent into internal exile in the closed city of Gorky. This is where foreign journalists and visitors were not allowed. There he was kept under constant surveillance, his communications were restricted, and he was cut off from most of his scientific and political contacts. Despite the isolation, he continued to write and speak out whenever possible. Earlier in his life, he had been celebrated as a hero of science and was awarded the title Hero of Socialist Labor 3 times. First in 1954, again in 1956, and lastly in 1962. But by the 1980s, because of his activism, the government stripped him of these honors, showing how far his relationship with the Soviet authorities had collapsed. He was finally allowed to return to Moscow in 1986 during Mikhail Gorbachev's era of reforms. These reforms sought to bring more openness and change to the Soviet system, and Sakharov's release was a symbol of this new direction. After returning, he continued his public work and was even elected as a member of the newly formed Russian parliament. He used this position to argue for political freedom, transparency, and human dignity. He passed away in 1989, just before the Soviet Union began its final collapse. His death marked the end of an era, but his influence remained strong. Today, his legacy continues to be honored around the world. The European Parliament created the Sakharov Prize for Freedom of Thought in his name. It is awarded annually to individuals or groups who defend human rights and freedom of expression. This prize ensures that his work and his values are remembered by new generations. His life serves as a powerful reminder of how one person can move from building weapons of destruction to becoming a symbol of peace and justice. His contributions to both science and human rights make him one of the most remarkable figures in modern Russian and world history.